Alright, welcome to Screencast on the atom. Guiding question is, how are the smallest bits of matter described? So key ideas from this screencast are that the atomic theory, which is the idea that all matter is made up of atoms, is a really old idea, dating all the way back to the ancient Greeks. Democritus, the man I referenced in class, you're talking 2,500 years ago, was when he was, having these thoughts of, well, what happens when you cut matter in half and half and half and half and half? What is the smallest chunk of matter you can get to? Anyway, his ideas laid dormant for thousands of years because what he didn't have was data. It was just his idea. So he was, for the most part, ignored. Anyway, these atomic models, now that we have, beginning with Dalton, help scientists picture and explain observed behaviors of matter. So when you mix two things together and you make observations of what occurs, you can make predictions about what's going to occur if you have a little knowledge of the atom. Anyway, scientists alter and revise these models as new scientific evidence accumulates, just as any model morphs over time. Anyway, scientists are now in agreement that the atom consists of a central nucleus with electrons surrounding it. Okay? Alright, so to answer this question, you will explore the atoms, which are the smallest bits of matter, models of the atom, of course, and then which you did in class already, and then the simple atomic model. We'll reference that. Alright, this drawing depicts a very tiny sample of gold taken from a gold ring. The spheres in the cube are are so small that they cannot be seen with the naked eye. What are the spheres, and what does this drawing tell you about the element gold? Now, in class, we looked and we talked about, this is a model of a chunk of gold, and models help us visualize things that are too small to see. And so we said that these individual spheres were individual gold atoms. And of course, we cannot see atoms with our naked eye, but we can see atoms using the assistance of certain microscopes. The naked eye has actually a resolution of about 100 microns. So atoms are separated by about 1/10 of a nanometer. That's so small, we could barely see, a tiny grain of dust. And that grain of dust is actually millions and millions of atoms wide or across. So we're not even close to being able to see them with our naked eye, but using some instruments like the electron microscopes that we have, you can actually see the arrangement of atoms. In this case, we see these carbon atoms arranged in this 6-member ring. Pretty cool. And you'll see some other pictures as we move through the screencast. Anyway, as mentioned before, around 460 BCE, the Greek philosopher Democritus wondered, if you break a piece of matter in half and then break it in half again and again, how many times can you do this? Can you continue forever? And it was Democritus and his idea then that really started the path to this model of the current atom. Anyway, he thought if you could break this matter in half and in half and in half again, as I've done with this gold ring on here, that you'd eventually end up with the smallest bit of matter possible. Okay, and Democritus predicted that eventually you would reach something that is uncuttable, and so came the word atomos, meaning indivisible. Okay, so oops, I got ahead of myself there. Anyway, here's the etymology of the word, Greek atomos, and that means atom. Not cuttable. Here are some other pictures of some actual microscope images of atoms. Now these are done with, most of them are done with a transmission electron microscope, or TEM, and what you see are these basically, there's a few ways that it's done, and you don't need to remember that, but anyway, it's basically just dragging something over the top of a material, in this case, in the middle here, and it reads the surface of this material, and so it's actually picking up on individual atoms here, and so that's what you're seeing there. And IBM actually started this process, or was the first company to actually be able to see these individual atoms. And this technology existed in the 80s. So that's where this picture comes from. And these are the individual atoms of a material that I don't know what material it is, but pretty cool. Anyway, 1803, British scientist John Dalton suggests the idea that atoms could help explain why elements come together in these specific ratios when they form compounds. And we've already seen that with a couple of the activities we've done. Anyway, he imagined atoms of different elements combining to form compounds in ratios specified by the chemical formulas of those compounds. For example, if hydrogen came together with if oxygen came together with two hydrogen atoms, then you'd see one water molecule with a ratio of 2 hydrogens to 1 oxygen. And so became Dalton's theory, or atomic theory, and now we refer to it simply as the atomic theory. But anyway, Dalton had more than just these ideas. Okay, he was different from Democritus in that he actually ran experiments and made observations and came to these conclusions. Anyway, he was kind of the first, I guess you could say, modern, starting in 1803, scientists to start working on this atomic theory, or model of the atom, that is. So the atomic theory states that all matter is made up of atoms. You'll have to get that on your paper. But in science, it's really important that we make the distinction that a theory is not, an educated guess. A theory in science means that the explanation is supported by an overwhelming amount of evidence, and that support is coming from all over the world in different laboratories, and they're all doing research on the same topic, and all of the different research is just making the theory grow stronger and stronger. Okay, so it's really important to understand that we don't use theory to represent guess or educated guess. Theories are essentially law. Okay, meaning is there room for them to be proven wrong? Yes, absolutely. Okay, the word theory allows room for doubt and revision, but it again indicates a great degree of certainty that the word does not mean in everyday use, as many people use it around you. Anyway, models of the atom. So since Dalton's time, scientists have created many models to describe the atom and the parts of the atom. Okay, models again are just simplified versions of something that you want to explain. Okay, and I want you to get this definition down: simplified representations of something more complex that help with understanding certain aspects of the real object or process. And we've used the globe as an example in class. It's a little hard to study the Earth in its natural state unless we were from, if we were in space and we were able to look back at the Earth. So we use this globe, and this this size of this globe that fits into your hands is a little bit easier to study than the world itself. Anyway, models take many forms. Okay, they can be mathematical equations, they can be a physical model where you can take parts out and look at them and see their arrangement, as is the case with this human body here. And they can be drawings or pictures. Okay, they could be even a mental image. So the word model is used loosely to describe all of these things. Anyway, the very first model of the atom was Dalton's, and it was just this hard, solid sphere like you saw in class. But over time, after experiment, this model of the atom has morphed. Okay, and here is kind of a timeline of what those look like and the contributions that each scientist made. Again, no single contribution was invalid because it kind of led to the next hypothesis, okay, and it led to the next observations and so on. So you couldn't just get to this ultimate model here without having first used what previous scientists worked on to help form your, new question and then new hypothesis. So the 6 models here that you see have something valuable to offer then, and none of them are useless, so to speak. So here is then our ultimate simple atomic model that we're going to get really good at drawing in class. It is made up of a nucleus, and you can get that down there. It's the dense positively charged structure found in the center of the atom. It's composed of both protons and neutrons. You see two different colored spheres there. Protons are particles with a positive charge that are found in the nucleus, and neutrons are the particles that don't have a charge that are found in the nucleus. And again, we see nucleus right here in the center of the atom, okay? And then electrons are these particles, these really tiny particles that are have a negative charge, and they're zipping around the outside at different distances from the center of the atom, okay? The big idea here then is that an atom has a nucleus which is made up of protons and neutrons with electrons orbiting the nucleus, and each electron has a charge of -1. The neutrons are neutral, they have no charge, and the protons are have a charge of +1, okay? And most atoms are neutral. We'll talk about an ion, which is an atom that is not neutral, but most atoms are neutral. They have no overall charge, which means it's, then that the number of protons is equal to the number of electrons. Groovy. And I would like you to consider these questions about the model. I'm going to skip forward. How small exactly is, or not exactly, but how small is the nucleus of an atom? Well, we know that there's lots of different atoms that make up the different elements, but if you looked at the average, you would find that if we took this baseball stadium and we said this baseball stadium three-dimensionally was the size of an atom, if it were, then the size of the nucleus would be smaller than that baseball, somewhere between the size of a marble and a baseball. Kind of remarkable. Take-home message, how are the smallest bits of matter described? Well, there's a summary of what we talked about. You can summarize on your notes. You don't have to write word for word all of that, but you do need to summarize. Have a wonderful night. I will see you tomorrow. Cool.